Got this little zigzag looking thing going on. All right, so here's what we do. We look at what we're given, and then we just one by one kind of see what we can piece together. Now, it tells us over here, the measure of angle, and you got to be careful here because your angles and your arcs are going to use the same letters, so you got to read the symbols along with it. Angle E, there's E to D to F, is 15 degrees. So I'm going to mark that because it's not written on my diagram. Determine the measure of angle ABE using appropriate theorems and postulates. So A to B to E is right here. Both of these combined. That's my goal. So here's what we're going to do. If we need to find A, B, E, we need to go from here all the way over to here. So we're going to do some arc addition to figure this out because we know this part's 44, and then we can use this angle down here to figure out this arc. So if you need to, look back at your notes and see what that relationship was between the inscribed angle and the arc that it subtends. If the inscribed angle is 15, how much should this arc be? Good, because it's twice as much. So now we can use this arc addition postulate to say, well, if this part's 44 and this part's 40, then the whole thing is going to be how much? Good. And then same thing that we did with this 15 and 30, but now we're going backwards. If the arc is 74, I need half of that to find ABE. So half of 74 would be 37. And there you go, you found it. Right? Not a whole lot of complicated stuff, just some times 2 and some multiplying by 2. Now we could do some other things in there because this set of endpoints goes for both angle D and this small sliver of angle B. We would know that this part down here is 15, and then we could subtract from 37 and find out what this one was. We could do all kinds of other stuff, but we're just going to kind of take it one little piece at a time, knowing that eventually you might have to do a whole diagram like that. Okay, so flip on over to 786. We're going to do some naming of chords and arcs first. Not too much, though. We're just going to do like probably numbers 1 and 2. Identify the chords, inscribed angles, and central angles in the figure. The center of the circles in exercises 1, 2, and 4 is C. Now, notice you don't have it on 3, but that's okay. So the center is C. So somebody name me a chord. A chord is a line that goes from one part of the circle to another part on the end points, or on the circumference of the circle. Good. So ED or DE, that would be a chord. And it's a line, so we're going to draw that line, or it's a line segment, really. Name me another one. Good, EF. You could name them backwards as well. DE, ED, that's fine. EF, FE, that's fine also. So now, let's move down and look at some inscribed angles. Inscribed angles, there's only one, actually, yeah, there's only one of them here. An inscribed angle has its vertex on the circumference or the perimeter of the circle. So give me a letter first, a single letter for the vertex. E. Yeah, so E is inscribed. Let's actually name it with all 3 points though. So you've got D, E, F. Or FED. You could do that in reverse also. Yes, ma'am. Yeah, I just sent it. Thank you. So now we have a central angle. So somebody tell me the vertex of the central angle. C, good. So angle, I'm going to name it with the 3 letters, DCF or FCD. That's fine too. Let's go ahead and flip over to numbers 7, 8, and 9. It says the center of the circle is A. Find each measure using the appropriate theorems and postulates. Now, notice that curve That's arc CE. Is that going to be a major arc or a minor arc? Good. Minor, only 2 letters. What about BEC? Major or minor? Yeah, major, because it uses 3 letters. So if we're trying to find CE, it's going to go from here down to there. Okay? So what are we going to do to find that total? Yep, you do. So the central angle in here is the same as the measure of the arc. And we know that the 2 angles measure 51 degrees and 90 degrees. So we're going to take 51 degrees and 90 degrees, and we're going to add them up, and that's going to be 141 degrees. And that's it. It's 141 degrees because the central angle is the same as the measure of the arc. Now let's look at DF. So D is over here, F is over here. Now I'm going around this way. Okay, this one's a little bit more challenging. We don't have a number right in here that we can add up. How could we figure that number out? Very good. Which one did you say? B and D make 90 degrees. Good. And the way he knew that is because BE is a diameter, goes all the way through. It's a perfectly straight line. And if you were wondering, you could have done the same thing with F and C. So because BE is a diameter, if this part's 90, this other part's 90, and then these 2 are going to be vertical angles. So in there, this will come from 90 minus 51. So you're going to have 39. Sorry. And that means this vertical angle is also 39. So now what 2 numbers are we going to add up? Good. 39, 90, 129. Then our last problem up here on this circle is arc BEC. Now the order matters here. So we're going to start at B and then go around so that we hit E and then C. So there's E and then there's C. And I realized that didn't trace the circle very well, but I didn't want it to I didn't want all my colors to run together. So you got 2 options. You can either add up everything, or you can subtract the one little piece that you don't need. I think it's easier to subtract. We've got this one little slice right here that we know is 39 degrees. And the whole circle should be how much? 360. The diameter would be 180. So 360 minus the 39, that's the only part we don't need. It's going to be 321. And there you go. Okay. Yeah, not too bad. A lot of multiplying by 2, a lot of dividing by 2, a lot of adding and subtracting. So the math itself is not super hard. Okay, let's do 10 and 11. Number 10 says arc BC. So here's arc BC. I'm going to give you a minute to think about that and see what you can come up with. Does anybody have arc BC yet? Good. And he knows that's 140 because this angle down here is 70, and those endpoints subtend or create arc BC. So an inscribed angle is half the measure of the arc that it makes. So 70 is half of 140. Then we have arc AD. Now it tells us up here that AC is 116, that's right here. And we have AD Right in there. Now that 28 is not going for arc AD. The 28 is pointing to the measure of angle DAB. So let me give you a second to think about how you might solve that as well. So your answer should be 48 degrees for AD. Somebody want to tell me how we got 48? So yeah, if you're, well, actually, so 28 times 2 is going to go right here. So 28 times 2 is 56. And that gives us BD, but we need this orange one over here. So now what? Oh, yay. Wax on the floors. All right, so how many degrees would be in the, which has circular pads on it. So anyway, just so you know, how many degrees would be in the whole circle? 360. So we're going to take that 360 and we're going to subtract 116 because we don't need that. And we're going to subtract 140 because we don't need that. And we're going to subtract 56 because we don't need that. And if I type that in my calculator correctly, that should be 48. I'm going to type it again just to be sure. Yep, 48. So what you have here is a little bit of indirect measurement. We didn't have a single angle whose endpoints were A and D, but we did have some other stuff that we could kind of piece together and add them up and then subtract it from what we know the total has to be. And that's going to be something that you need to do. I mean, you have to do that fairly often. So I feel like we're probably pretty good. I'm going to preview that next page because it's been about 3 days since I looked at it. Oh, let's go ahead and do 18 and 19. I forgot about this percentage stuff. This is good too. It's not hard. The circle graph shows how a typical household spends money on energy. Use the graph to find the measure of each arc. We're not going to do each arc. We're just going to do like one of them. So take arc PQ, starts at T, and it goes to Q. Am I drawing my arc to the right or to the left? To the what? To the left, to the left. Everything we own in an arc to the left. Why did we pick left? Good. It's a minor arc. We go the shortest path. Okay, so we're going from P to Q in the shortest path because we only use 2 letters. That's how we know it's a minor arc. If we went the other way, it'd be a major arc because it'd be more than half. So what percent of our circle is in that circle graph? 45. So how would we figure out the actual degree measure if we just have 45% and not like 45 degrees? We could find 45% of what? Yep, 360. So we're going to take 360 and multiply times 0.45. I'm not that good, so I'm going to type it in. I don't trust myself. 162. Okay, that is how that works every time. You can do this with degrees. You can do this also with percentages. But sometimes, again, you're going to have to rely on that fact that there's 360 degrees total in the whole circle. And now I think that's about all. So let's look over at your IXLs that you've got for the day. a new distance.